Hello, this is Mrs. Ward, and I'm going to go over the classwork for section 9.6, which is on polar coordinates. We've separated this video into two, so I'm going to go over the first half now. So in exercises 1 through 4, they want you to find the point in polar coordinates. The point is given to you in polar coordinates. They want you to find the corresponding rectangular point. So we're going to use that formula that says r is equal to, well, x is equal to r times the cosine of theta, and y is equal to the r times the sine of theta. So that's what we're going to use for each one of these. Remember, when we have polar coordinates, they come in the form of the radius and then theta. So for number 1, I'm going to find x, I'm going to say 4 times the cosine of pi over 2. 4, the cosine of pi over 2 is 0, so I'm going to get 0. Then for y, I'm going to say y is equal to 4 times the sine of pi over 2. So 4 times the sine of pi over 2 is 1. So then I'm going to get 4. So my ordered pair is going to be the ordered pair 0, 4. So that's the ordered pair here, 0, 4, which if I'm looking at this, they plotted it on the rectangular system, and that does make sense. I don't move to the left to write it out. I go up 4. So then I have 4, 0. Now I'm going to do number 2. Number 2 is basically, it's the same thing. So I'm going to say x is equal to 4 times the cosine of 3 pi over 2. The cosine of 3 pi over 2 is 0. So this is going to be 0. Y is going to equal to 4 times the sine of 3 pi over 2. The sine of 3 pi over 2 is -1. 4 times -1 is -4. So that ordered pair is going to be 0, -4. And checking, that does make sense because I don't move to the left to right at all, and I drop down 4. Number 3, x is going to equal r, so -1 times the cosine of 5 pi over 4. Remembering my unit circle, I'm going to say that the cosine, and I'm going to do from a unit circle, I'm not going to give a decimal. The cosine of 5 pi over 4 is going to be a negative square root of 2 over 2. When I multiply that by -1, I'm going to end up with a positive square root of 2 over 2. For the sine, I'm going to say y is equal to r -1 times the sine of 5 pi over 4. So I'm going to have -1. The sine of 5 pi over 4 is going to be a negative square root of 2 over 2. When I multiply, I'm going to get a positive square root of 2 over 2. So this ordered pair is a positive square root of 2 over 2. Positive square root of 2 over 2, which does make sense because here this point's in the first quadrant. Both of these are positive, so that does make sense. Now I'm going to do the last one, number 4. R is equal to, x is equal to r, which is 2 times the sine. Oh, I am messing up all over the place. So sorry. Let's try that all over again. So I am going to say that x is equal to r times the cosine of pi over negative pi over 4. And my r was 2, so 2 times the cosine of negative pi over 4. And so I'm going to have x is equal to 2. The cosine of negative pi over 4, and remember negative pi over 4 puts me down the fourth quadrant. The cosine is positive, so this will be the square root of 2 over 2. When I multiply these, the 2's will simplify, and I'm going to end up with a positive square root of 2. To find y, I'm going to say y is equal to the r, which is 2 times the sine of negative pi over 4. So this will be 2. The sine of negative pi over 4 is a negative square root of 2 over 2. When I multiply, the 2's will simplify, and I end up with a negative square root of 2 over 2. So my ordered pair is the square root of 2 over square root of 2, negative square root of 2. Just like that. And that does make sense. This is positive, this is negative, which does put it in the fourth quadrant, so it seems to be correct. Going on to the next one. It says plot the points in polar coordinates, then find 3 additional polar representations of the points. So I put the same graph paper on this slide that's on the Blackboard quiz that you'll be taking. And this is the same paper that we'll use on any assessments, tests, quizzes. So explain this paper. This starts my radius. So there's a radius of 1, 2, 3. This dark one is 4, 5, 6, 7, 8, 9, 10. So it goes out 10 radiuses. And then this one, this would be 0 degrees, 90 degrees. Whoopsie. In radians, that's 0, pi over 2. This would be pi. This would be 3 pi over 2. And then on this paper, each one of these darker lines will be pi over 6. So this is pi over 6. And this is 2 pi over 6, which is pi over 3. So if I have one with pi over 4, I know it's going to be like halfway between that pi over 6 and pi over 4. All right, just thought I'd explain the paper. So here we are, number 5. I like to find my angle first. My angle's 5 pi over 6. 5 pi over 6 is in the second quadrant. 5 pi over 6 will be this line right here. And then I want a radius of 3, so I'm going to count out 1, 2, 3, and I'm going to plot my point right there. So that's me plotting my point. Now to find 3 additional points, I like to start off with keeping my radius positive, but instead of doing my angle this way where I'm going in a positive direction, I'm going to do my angle this way where I'm going to go in a negative direction. Remember, these 2 angles together add up to 1 rotation, or 2 pi. So I'm going to take 2 pi and subtract that 5 pi over 6. And that's how I'm going to get, oh no, I said that wrong. I'm going to take 5 pi over 6 and subtract that 2 pi. And I'm going to get negative 7 pi over 6. So starting here, going all the way around would be negative 7 pi over 6. So those are my 2 with a positive radius. Now I'm going to say, well, what happens if I, instead of using this line here, I'm going to use this line here. So if I use this line here, that would be 11 pi over 6. If I started from here and went all the way around, that would be 11 pi over 6. And since I want to skip over the origin, so because I'm on this line, I want to skip over the origin, I'm going to make this a negative 3. And then if I take 11 pi over 6 minus 2 pi, I'm going to say negative 3 and then negative pi over 6. So those are my 4 representations of that one point. That's being the first, this being the other 3. Let's try and do that again. So the next one, I have 5 times the square root of 2, which I'm going to do a decimal approximation for that so I know where to plot it. And when I take 5 times the square root of 2 on my calculator, I get a decimal of approximately 7.07. So approximately 7.07. That's where I'm going to plot it. Negative 11 pi over 6. If I start here, negative 11 pi over 6 will take me all the way around the circle. And then this would be negative 11 pi over 6 going this direction here. So plotting 1, 2, 3, 4, 5, 6, 7. I'm going to plot it right there. Well, yeah, if I make the dot big enough, close enough. All right, so that's my plot. Now, this went negative 11 pi over 6. If I would have just done this angle here, that would have just been pi over 6. So I'm going to have 5 square roots of 2 and then pi over 6. Now I'm going to find the angle that's halfway across the unit circle. Remember, to find halfway across the unit circle, I can take this pi over 6 and add pi. So that'd be 7 pi over 6. And since that's this line here and I want to hop it over the origin, I'm going to make my radius negative. And then if I want the one that's, so this is positive 7 pi over 6 going from here to here is positive 7 pi over 6. Now if I want from here to here, I'm going to take that 7 pi over 6 and subtract 2 pi. So 7 pi over 6 minus 2 pi. And when I do that, I'm going to be negative 5 pi over 6. And then my radius, since I'm hopping over that origin, will be negative 5 square roots of 2. And those are all my representations of that one point. So polar coordinates is a little bit different than rectangular because I can have multiple representations to name the exact location. Okay, number 13 through 20, you're supposed to plot the point given in polar coordinates and then find the corresponding rectangular coordinates for the point. So negative pi over 3, I like to do the angle first. Negative pi over 3 is down here somewhere. well, here. And then I want a radius of 4, so I'm going to count 1, 2, 3, 4. So that will be this point right here. To find my x, I'm going to say x is equal to r cosine theta. That's the formula. So x is going to equal 4 times the cosine of negative pi over 3. So for the cosine of negative pi over 3 is a positive 1/2. So x is equal to 2. Now, then to find my y, I'm going to say y is equal to r sine theta. So y is equal to r times the cosine, sine. I just wrote it, negative pi over 3. And the sine of negative pi over 3 is going to be, this is 4. So we have 4 times it, so it'll be negative square root of 3 over 2. The 4 and the 2 will simplify, and I'll get y is equal to negative 2 times the square root of 3. So this ordered pair right here is going to be the ordered pair 2, and then negative 2 times the square root of 3. And I like to do a check to make sure. This point, positive, negative, would be in the 4th quadrant, and where I plotted this point is also in the 4th quadrant, so it looks like it's a good match. All right, number 18, I have a radius of 0 and a angle of 5 pi over 4. 5 pi over 4 is in the 3rd quadrant, so it's this angle here. Remember, it's like halfway between these two, so it's somewhere in here. But if I go to do this, I'm going to say x is equal to my r, which is 0, times the cosine of 5 pi over 4. Well, I don't even have to know that the cosine of 5 pi over 4 is a negative square root of 2 over 2, because I'm taking 0 times that. So 0 times anything is going to be 0. So the x-coordinate will be 0. And then when I go to the y-coordinate, it's going to be the same thing. Y is equal to 0 times the sine of 5 pi over 4. Again, 0 times anything is just going to be 0. So this ordered pair is 0, 0. And here's my angle, 5 pi over 4. If I'm not doing any radiuses, I'm just staying at that center, the pole, I believe. The next one, I have decimals, which probably makes most of you happy, because that means if you have a decimal, that means you can use your calculator. I'm not expecting you to get the value off your unit circle. So when I do this, I'm going to say x is equal to my radius, which is negative 3, times the cosine of negative 1.57. So I put this in my calculator, cosine of negative 1.57, and when I do that, I get something very close to 0. I got point, and I think there's 3 zeros, 796, I think. And then when I take negative 3 times that, it's going to equal a negative 0.0024. And then when I do y, this y is equal to this negative 3 times the sine of negative 1.57. And when I put sine of negative 1.57 in my calculator, it gives me 1. So I'm going to have I'm going to have negative 3. So technically, based on this, my ordered pair would be negative 0.0024, negative 3. Well, if you guys remember from trig, when we separate this, we had 0 and we had pi over 2. Oh, it's negative pi over, so this is negative 1, so that's positive 3. So when we did this, we had 0 pi over 2 and then pi, and then we did do, when we talked about the radians, we did say, well, this was 0, and we did say this was 3.14, and then when we took 3.14 and divided by 2, we did get 1.57. So going this direction, this would be a negative 1.57. So when I plot this point, negative 1.57, negative 3 would be 0, 1, 2, 3. That would be right there. Okay, moving on to the next one. It says an exercise, and the following exercise, plot the given point in a rectangular coordinate and then find two sets of polar coordinates for the point. So if I plotted 1, 1, I plot 1, 1, I'm going to go over 1, up 1, and there's 1, 1. So now I want to change this to a polar coordinate. So in order to do that, I am going to, I'm going to find my line first. So I'm going to say tangent of theta is equal to y over x. And I'm going to write that because they're both the same number. So I'm going to say the tangent of theta is equal to 1 over 1. In my calculator, I'm doing the inverse tangent of 1 over 1 is equal to theta. And it'll give you some decimal. But if I change that decimal to degrees, I see that it's 45 degrees. Or I can think of it as pi over 4 because they represent the same thing. So remember, polar coordinates has the radius and then your angle. So we've just found the angle to be pi over 4. Or we can say the angle is 45 degrees. Now to find r, remember r squared is equal to x squared plus y squared. So r squared is going to equal 1 squared plus 1 squared. So r squared is going to equal 2, which means r is equal to the square root of 2. So this is the square root of 2, square root of 2. So if I were to plot this, this would be my angle pi over 4. And then I'd have 1, 2, square root of 2 is about 1.4, I believe. So it's going to be halfway between the 1 radius and the 2 radius. Okay, let's look at number 36. I'm going to find my angle first. I'm going to say the tangent of theta is equal to 12 over 5. Now when I do that, I get, on my calculator, I get a decimal. I'm sorry, I thought I had it done. I don't have it done. So I'm doing the inverse tangent of 12 over 5 on my calculator. And my calculator is going to give me 1.18 when I round it to 2 decimal places. And now, and if I change that to degrees, I get approximately 67.4 degrees. Either one is acceptable. Then r squared is equal to x squared plus y squared. So r squared is equal to 25 plus 144. R squared is equal to 169. Square root. R is equal to 13. So my ordered pair is going to be 13. And then either 1.18 in radians, or I can say 13 and 67.4 degrees. And I believe that ends, no, yeah, I think that ends the homework. All right.